Assalamualaikum and hi everyone. Welcome to our YouTube channel. My name is Nurjana Safia. Today we will going to discuss about how to determine calcium carbonate in eggshells using back titration. But before that, let's meet our group members. Do you know what is titration? Titration is an usual way that can quantitatively identify the unknown concentration of an analyte until the reaction judged to be complete. There are several types of titration, which is direct titration, back titration, and curve titration. Now, back titration has been chosen as our topic. Back titration can be defined as a titration where the concentration of an analyte is determined by reacting it with a known amount of excess reagent. Then the remaining excess reagent is titrated with another second reagent. The aim of this experiment was to measure the percentage of calcium carbonate in eggshells. Since this reaction slows down significantly as it approaches endpoints, it cannot be used to titrate calcium carbonate directly. However, the amount of acid that did not react with the calcium carbonate is determined by titrating remaining excess acid hydrochloric with sodium hydroxide solution after adding an excess of acid to dissolve all the calcium carbonate. The amount that the calcium carbonate uses is equal to the difference between the amount of acid hydrochloric that was initially added and the amount that is left over after the reaction.
Next is the theory related to the application revolves around the use of back titration to determine the calcium carbonate content in various types of eggshells. The applies chemical analysis techniques to evaluate the calcium carbonate content of eggshells. Back titration is used because the direct titration of calcium carbonate is impractical due to its low reaction. By reacting it with excess hydrochloric acid and then titrating the remaining acid, the amount of calcium carbonate can be determined indirectly. This method allows provide a reliable approach to quantify the calcium carbonate content in various eggshells. Additionally, scanning electron microscopy is used to study surface structure of the eggshells, providing insights into the physical characteristics such as thickness and porosity, which can vary between species due to environmental factors, diet, and genetic traits.
Hello, my name is Nurtalika Anissa binti Muhammad Yunus. I am going to talk about the procedure of this experiment. First part is standardization of sodium hydroxide solution. Firstly, fill a burette with the sodium hydroxide solution. Second, pipette 20 ml of the standard potassium hydrogen thalate solution into an Erlenmeyer flask. You can ask your instructor for the exact concentration of this solution. Then add 2 drops of phenolphthalein indicator. Thirdly, titrate the potassium hydrogen thalate with the sodium hydroxide solution. Then repeat the titration 2 more times. Lastly, we can calculate the concentration of the sodium hydroxide solution. After we are done with the first part of the procedure, we are going to proceed with the second part of this procedure. The second part is standardization of the hydrochloric acid solution. Firstly, pipette 10 ml of the hydrochloric acid solution into an Erlenmeyer flask. Then add 2 drops of phenolphthalein indicator. Second, titrate the hydrochloric with the sodium hydroxide solution from the burette. Then repeat the titration once. If the result is not close to the first one, carry out another titration and calculate the mean volume. Lastly, calculate the concentration of the hydrochloric acid solution. And we are done with the second part. So we can proceed with the last part of the procedure, which is analysis of the eggshell. Firstly, obtain some dried eggshells with the inner membrane being removed. Then grind the eggshell in a mortar into small particles, about a size of fine sand. Second, weigh about 0.5 gram of the eggshell in an Erlenmeyer flask. Third, pipette 25 ml of the standard hydrochloric acid solution into an Erlenmeyer flask that contains the eggshell. Wait for about 2 to 3 minutes for the reaction to complete. Fourth, heat the reaction mixture to boil, cool it down and add 2 drops of methyl orange indicator. Titrate the mixture with the sodium hydroxide until color change to yellow. Then you can repeat steps 2 to 5. Then we can calculate the percentage of calcium carbonate in the eggshell in each replicate. Lastly, calculate the mean percentage of calcium carbonate in the eggshell.
For the results example, we have prepared 3 different tables. The first one is the standardization of the sodium hydroxide solution. The second one is the standardization of the hydrochloric solution, and the third one will be about analysis of the eggshell. For this procedure, we have weighed the eggshell to be 0.5 gram. For the bite titration equation, the first one is the calcium carbonate with 2 mole of hydrochloric acid and produce calcium chloride with water and carbon dioxide. For the second equation is sodium hydroxide with hydrochloric acid and will produce sodium chloride and water. For the calculation example, we choose to show how to calculate the percentage of calcium carbonate in eggshells for replica 1. First, we have to use the formula of M1V1 equal to M2V2, and then we also have to find out the number of mole of HCl used and reacted. From using the equation 1 from the back titration, we can also find the number of mole of calcium carbonate, and from there we can also calculate the mass by using number of mole times molar mass, and we will get 0.254 gram, and from there we can also calculate the percentage, and the final answer will be 50.8%. 2 precautions during experiment. The first one is always have to check for air bubbles inside pipette and burette to avoid calculation errors. For the second one, make sure to shake the flask continuously during titration to avoid excess nitrate going inside the flask and mess up the calculation afterwards.
And next we have advantage and disadvantage. We have 3 points of advantage and disadvantage. The first one for advantage is accurate quantification of calcium carbonate. The back titration method allows for precise determination of calcium carbonate contents in various types of eggshells. The use of chemical analysis provides a clear, reliable measure of calcium carbonate percentage. Second is comparative analysis across species. It compares calcium carbonate content in eggshells from multiple species, which helps in understanding interspecies in differences. Lastly, for advantage is biological and environmental insights. The relationship between eggshell structure and external factors like environments, habitats, diet and mineral nutrition of animals. This has implications for both scientific understanding of eggshell formation and potential applications in agriculture, especially in poultry farming. For disadvantage, the first one is time-consuming procedures because back titration method involves several steps, including dissolving the eggshell powder in acid heating, cooling, and performing titrations. This can be labor-intensive and time-consuming compared to other potential analytical techniques. The second one is species-specific variations may limit generalizations. The findings, especially regarding the calcium carbonate content, are specific to the species study. Variations in diet, habitat, and genetics can lead to differences in eggshells compositions, meaning the result might not be applicable to all avian or reptilian species globally. And lastly, for disadvantage is limitations of surface analysis. It is limited to the outer structure of eggshell. It does not give direct information about the inner chemical composition or other hidden layers beneath the surface, which might also affect eggshell quality.
The conclusion of this experiment is calcium carbonate is one of the main factors contributing to eggshell quality that in turn is a feature of the obviously successful reproductive strategy. The experiment's goal of figuring out how much calcium carbonate was in the eggshell was accomplished. The mass percentage of calcium carbonate in the eggshell was found to be 50.65% based on the experiments.